funk it up tonight. So welcome to SkyTour LiveStream here in northwestern Connecticut. The image on the screen is the SkyTour LiveStream Observatory. We know it as the John Zach Memorial Observatory, named after a friend of mine who was going to be part of this project with me. Sadly, he passed away some years ago, but the memory and the vision lived on, and there it is on the screen. We have reached that fruition, and the telescope is going to be moving to Arizona, hopefully in the next year or so. And I'm heading there actually Monday for a week. I have to do a couple of talks, but I'm also going to be scouting for areas where I can bring what you see on the screen to Arizona under very dark skies. That is really exciting. Hey, welcome Dee, welcome Evan, and where's your mother? Nice to see you guys here. I will be kicking in here in just a few minutes. We have some interesting skies tonight. They're not the best, but they're actually not the worst. I have to tell you about a new piece of apparatus I have for the observatory, I should say. I'll be back to you in a moment. Hello there, Marianne. Good to see you here. Actually, Marianne is the one who's going to be picking me up from the airport when I get there on Monday, just a few hours from now. I didn't tell anybody I was going to be doing a stream tonight, so I didn't tell Daryl, I didn't tell Amanda, because I wasn't sure I was going to do a stream, but I decided I was just going to do one, and bottom line is, it's a matter of simply clicking the area on the screen that says, stream now. It's actually pretty intimidating when you never did it before. The first time I did that, it was just amazing. I sat there and just hovered over the mouse button with my finger, just thinking, oh no, I'm just a click away from either total disaster or total success. Luckily, it seemed to be a mix of both, so that was good. But hey, what can I say? It's actually pretty exciting, It's more exciting to actually have an observatory at your disposal where you can just go out and view the night sky whenever you want. It's really, really nice, man. Hey there, Bonnie. I see Bonnie's joined us. Welcome. I haven't talked to you in forever, it seems. I met Bonnie when I was in Las Vegas, and she has some very interesting history and so forth with the UFO arena, so to speak, and I think it's pretty interesting. All these people you talk to, But I am also looking forward to doing some real science. I might actually be going to Norway in August. It's looking more and more like that's a reality. And I would like to see, I'd like to see what happens when I get there, if I can survive these 6 hours ahead that they are. But I'm scheduled to speak in Oslo and I think Bergen now. That'll be interesting. And my talks are going to be on it seems to be very popular that people want to hear about what I do with my science when I have other competing theories in my own head about what's going on. Because, in other words, where does science go in the face of the unexplained? That's actually one of the talk's names. So it's pretty cool. And I'm thinking now, let's see, I'm going to be out there Monday in Arizona for the week, and then let's see, I'm thinking here on the fly. Thinking on the fly, which sometimes doesn't work for me. It's okay. Anyway, I'll get back to it, I'm sure. So tonight I was going to just show us I'm going to show all of you a few things that are in the location of Cygnus the Swan. Where's that? Well, I will show you with our handy dandy little planetarium. Okay. Now let's zoom out. Okay, and this is where we are. Then you say, well, what's that? Well, what that is Cygnus the Swan, and this is the swan right here. This is the bright star Deneb. Let me just get rid of the objects. This is Deneb right here. This is Saturn, which is the central star, also known as Gamma Cygni. Okay, and then we have this star over here. In Cygnus, we have this one down here, and we have this one. This is beautiful Albireo. Albireo is a beautiful, beautiful double star. It's a B8 star with a K star, meaning it's blue with a reddish orange component, which is absolutely gorgeous. While we're here, why don't we actually go look at Albireo? So I'm going to head on over there now. All right, so we're going to tell the telescope to get its butt over there, and we should see the stars whipping by, and we do. And you can see in these small windows here, you can actually see the telescope moving. And there is Albireo right there coming into view. We don't see the color yet, but don't worry, we will. I'll make sure you see it. And where's your mother? Yes, you do see stars. And not from getting whacked on the head. You see them here in the telescope. We're looking right now at a telescope which is giving us a really nice close-up view. This is a double star you cannot see without a telescope. And this is a close-up of it right now. And actually in this close-up you can actually see the bluish component here and a little bit of orange there. All right, so I just kind of did a dynamic telescope view here from inside. And now we're going to do a exposure. Let's go do here an exposure. And for those that have been here before but don't remember, or those that wish to just understand what's going on this darn screen, this is our telescope control system over here. All things telescope get controlled here. This controls the computerized elements of the telescope, and I've memorized what most of these numbers and functions do. Down here is the dome ops. That's me in the warm room if it's in the winter, and I'm actually inside. These are the monitors that you see right in front of me. These monitors control all systems. Up here is the camera control, and down here are the dome cams. All right, and of course the title. And right in the middle is all of this. Now we don't have to, we don't actually have to have all this here. We can actually, get rid of a lot of that stuff. Okay, and we can look at the view as it is right now. We can see Albireo up there in the upper right. This is just an interesting it's another way of doing it's a remote close-up basically. But I can actually get rid of these things on the screen. All I have to do is do this. And I can get rid of our dome ops if I wanted to, if I want to just, knock this out of here for now. And basically, I could show you the entire screen, but we are going to see that pretty quick. It won't take long. All right, so let's do one thing, and that's just lower the music a little bit. So I'm going to do a 10-second exposure at an ASA of 3200. You can see over here in the camera operations segment, we have 10 seconds for 3200. And let's see how Albireo, right here at the head of the swan in Cygnus, looks for 10 seconds. And it'll be here any second. Kabam! Oh, this is stunning here. Check this out. right, so this is what it looks like, and this is a little instant processing to kind of show you what it's looking like. Looks really pretty. I love Albireo. Check this out. Is that not beautiful? Now you can see the colors for sure. You can see the blue here. This is that very hot B-type star. And this is a K star, which is a fairly large star. And it's really, really something else, you know? So these two stars are orbiting each other. They're several thousand astronomical units from each other. And they orbit over many years. You can't see it, okay, because it's really they're too far away to actually see the orbit change much over our lifetimes. But it really does move in the sky. Very, very cool. And so at this magnification, we can see some just beautiful detail. I'm gonna do this. I'm going to just change a little bit of the processing here for you, just to make this look a little bit better. 1 second. Let's go to this. There we go. All right, there. So now you can actually see a little bit. Sorry about the DOMOPS image there. It's not supposed to be there here. That's a little holdover. So there. So now you can see the entire view. That's the entire view right there. And we were zooming in on this one little area. This area of Albireo, the double star. It's beautiful. Yes, sirree. So I want to say hi there to Reviving. Nice to see you. Trigonometry's here. Dagger Spells, welcome. Justin T, good to see you. I said hi to D, and Jax is here. All right, welcome. I'm glad you subscribed. Thank you. We have a good time here. I really do. Hey, Rockstar, what you doing? See, a lot of these people, they become your friends, and they're kind of like friends and family. You look forward to seeing them, and when you don't see them for a while, you say, "Are they okay?" So anyway, I'm having some fun tonight. We're poking through the pre-summer sky, and the sky is actually not that good tonight. I mean, you can't really tell from this. I can. But it isn't really that good. Dalai, nice to see you. And so I just think that even so, it's still worth doing, because we have an awful lot of fun, and we're going to cruise through some of the beautiful stellar objects we can see. And so this is Albireo that we're looking at now. And where's Albireo? Well, I'll show you. Okay, over here in Cygnus the Swan. Okay, this is Cygnus the Swan right here. Okay, this is the tail of the swan, this is the wingspan here, and this is the head. How do I know that? Because the classical mythological character looks like this. This is the classical mythology for Cygnus the Swan. And so Albireo is actually the eye of the swan. If you close in, you can actually see that Albireo is right close to the eye. Right there, see? So it's kind of cool. And, when I was young, I was always looking at the sky and looking at the different constellations. And of course, we didn't see these images. We didn't even see this. We actually just saw, we didn't even see that. We saw this, okay, without the words. Okay, all we had was the stars in the sky. So when we looked up, this is what we saw, minus the little, minus any of the verbiage and stuff like that. Now, we're actually pointing at the star Albireo over here. The scope is just reporting the wrong position, which is why the indicator's there. I had it correct the other night, but it's a little miscommunication, but I'm not too worried about it, because it still points to the right place. And I see Ronald has joined us. Hi there, Ronald. That's ERRT Radio. If you haven't had a chance to listen to ERRT over on Mixlr, give it a chance, because our own Amanda Curran has a show there. She runs a comedy show, and she has a couple other shows. Amanda's also my co-host on Sunday nights for SkyTour Radio, which most of you already know, from 8 to 10 p.m. on Sunday nights, Eastern time. We have a great time, And Daryl's here. Where is he? There he is. Hey, Daryl. Nice to see you here. I know I didn't mention I was going to be doing it, but you know, I wasn't going to, and I just sort of the spur of the moment, I decided to run off and go ahead and be crazy and just do a stream. And it's okay. I mean, it's probably not going to be all that long, but I do want to have a shot at just checking out a couple of things. Actually, one of the things I want to show you guys, I want to go, because I did this earlier and it actually worked, and I'm going to do it again. This star right here is called the Double, okay? It's Epsilon 1 and 2 Lyra, all right? And we're going to go there, all right? And we're going to go there right now. I'll show you why when we get there. This is a crazy double star. A really, really interesting double star. And we're whipping across the sky right now. You see the stars pulling by. And then we got this all of a sudden showing up. It's like, whoa, what is going on there? Well, I'll show you. Because this is actually a double. It's a double star like you see here. One star and 2 stars. But then each of these stars is a double star in itself. It's the most crazy thing you've ever seen, if you've ever seen it. All right, so as an example, let's go over here. And this is our telescope controls I mentioned before. And what I'm going to do now is I'm actually going to zoom in a little bit. And you'll notice you can't really tell whether these are doubles. All right. However, you can if I start to change the parameters here. When I change these settings, you'll notice the screen is getting dimmer. See that? All right. And now when you look at this, you see there's something up here. You can tell that something's not quite right. All right. So what we're going to do is we're going to take an exposure of this. Okay. And it's 1/10 of a second at 800. I'm going to even go lower. Okay. I'm going to go down as low as I can go. Okay. And then we're going to just increase the exposure as much as I have to get it back. Let's go to 50. We're going to go right down to 50 ASA. It's the lowest possible brightness. And I'm just doing this now. Hang on one second. Don't worry about these things over here. This stuff is just it's magnification issue, so don't worry about it. Okay, so now we're there, and so what I'm going to do now is okay. Now let's take this picture. 0.7 seconds at 50 ISO. We're not going to see much, but the picture's already done. And now if I zoom in on this, okay, you'll see something interesting. You can see that this is actually 2 stars. Let me move it up a little. This is actually 2 stars. 1, 2. And this is actually 2 stars, but they're different. It's 1, 2. So these stars start at the lower left and go to the upper right. These stars go pretty much from left to right. So it's this side for it's this vector for these 2 stars, and it's that vector for those 2 stars. This is a double Epsilon Lyra. It's a fun thing to do with your telescope. You go out with your telescope and check it out, right? To your eye, it might look like this, but if you zoom in on it, you can actually see. And I know that we're going to the limits, but you got to understand that tonight is a difficult night. It's really not that clear, but you can actually see 2 stars here. 1, 2. See them? There's 2 separate stars there. And Ronald's asking, why are they double? Well, they form this way. So you see 2 here, 2, 1, 2, 1, 2. And they form this way, Ronald. This is how they formed. Most stars are born in clusters of stars, because that's where there's a big concentration of hydrogen gas. Okay, and that concentration of hydrogen gas will often spark star formation. And then when it sparks star formation, sometimes these stars will form in pairs or triples, and even more sometimes. Like Sigma Orionis has more than one component. Has, I think, 4 components, actually, minimally. It's a really interesting system. The bottom line is that in this particular case, we had these 2 stars, these 2 pair of stars that go around each other. We also have doubles, they're each doubles which go around each other within So it's sort of like a pair of spinning dumbbells, going around a common center, which probably is about here, over a long period of time. Just incredible. And so this is right over your head in August. It's directly over your head, right next to the brightest star in the sky, which is, and let's go back there now and check it out. Okay, it's this one here, which is a very bright star called Vega, and it's in the constellation Lyra. And if we back out a little bit, I can show you something interesting, because we have, in the summer sky, we have Vega right here, we have Deneb right here, and then Altair. This is Altair the Eagle. And how do we know it's an eagle? Well, we can always just show the eagle this way. Okay, there's the eagle. Okay, there's Cygnus the Swan, and there's Vega and Lyra the harp, the lyre. Okay, so we have the lyre, the swan, and the eagle. All right, and then these three stars within those constellations form what we call the summer triangle. Okay, we have Deneb, Vega, and Altair in the summer triangle. Interestingly, these stars were all the same spectral type, but they're in different stages of evolution. Vega is a normal star, as is Altair, but Deneb is a giant. And as a giant, it's actually probably going to end its life as a supernova at some point in the future. It's a giant star, but it's not the biggest type of giant star. The bigger stars are called O stars. You may remember we will go through the spectral chart of the stars. We've done this before. You have O at the hottest and bluest, and you have B, A, F, G, K, and M. So the B stars are stars like the Pleiades. When we look at the Pleiades, the seven sisters, they're bright and blue. You can actually see them when you photograph them that they're blue. Then we have the A stars, like we see here, these three I just pointed out. And then we had the O stars, actually, by the way, are like Orion's belt stars. Okay, Orion's belt stars are O-type stars. They're only going to live for a few million years, and then they're going to definitely explode as supernovas. And then the B's, Pleiades, A stars like here, F stars like Tabby's star. Tabby star is an F-type star. G stars like our sun. K stars like one of the components of Alpha Centauri. And M stars like every other star in the sky that you cannot see. There's more M stars in the sky than any other kind. And you can't see a single one of them because they're all too faint. You can see thousands and thousands and thousands of stars when you zoom in at night, okay? All right, but some of the stars are M stars, and you just wouldn't know it unless you could actually do a stellar spectra of it. And we've classified a lot of the stars, and a number of them are these M stars, okay? And they're often, they're sometimes hidden out in the middle of nowhere, but there's so many of them that it doesn't surprise anybody that these M stars have the most planets of any kind. The most planets are found around these M stars. So, where are we? We are over here at this one little tiny star. But we were just looking at Albireo, and I want to take us to a different place now. And that place is going to bring us over to... Let's just turn on our fun things here. Let's go and look at this little planetary nebula right here. This is called the Footprint Nebula. And it's actually fairly faint, but we're going to try and locate it anyway, even tonight when the sky is not that good. So let's head on over. Let's instruct the telescope to move, and it's moving. All right. And we should see some motion going on here. And we do. Indeed we do. Okay, and I see some motion there. We should be all set. Let's go here, check out that we stop moving. We have. And let's do, let's get out of 50 ASA and jump up to an even higher value. Let's go up to, say, you'll notice the stars coming in as we do that because we're getting a preview, a little bit of a preview. Let's go to say 8,000, And let's go for like 5 seconds. 6 seconds. Okay, I can do 5 seconds on the camera out there, but in here it can only go to 6. I don't know why. So let's do it. Let's check it out for 6 seconds. Let's go see what we got. We should be able to see the Footprint Nebula if the weather is conducive. All right, and I'm looking. I don't. Is that it right there? Maybe. Yes. Yes, you can see a distinct difference here. Look at that. Okay, that's a planetary nebula. That's what happens to a star when it's in the process of dying. It sheds its outer layers. Okay. And let's just zoom in again to see it. Okay. And so it sheds its outer layers, and by shedding its outer layers, it leaves a very, very hot white dwarf in the center. And that white dwarf is the very, very hot and ultraviolet and blue, hence the blue color you see here. So this is one of the stars of many in the view. And when we look at something like this, we have to say, wow, how do we ever figure that stuff out? Well, you can imagine there's a lot of stars out there, and every one of these stars has had some type of analysis done on it. Don't ask me why we know that that's true, because as an astronomer, I did some of these analyses when I was working on stars. I found stars that were speeding out of our galaxy at high speed. B-type stars, actually. So, very, very hot, young stars that were moving at very high speed, probably ejected from their star clusters. And then I did a lot of work looking at stars that are close to us, and that was a parallax study in the observatory. And I might have told you this before. I think some of you have heard this. I spent the midnight to dawn hours in the observatory, and then went to classes to get my degree in astronomy from 7 in the morning until 8 o'clock at night, and then would sleep for an hour or two here or there, and then go back into the observatory from midnight to dawn again, all winter long, all summer long. This was a year-round project. So this is what you do when you want to do this, and some of you know this. When I was 9, I was going to be an astronomer. I said so, and I followed through on it. Why? Because look at this. What do you mean, why? Look, it's beautiful. The universe is a beautiful place, and when you look at the universe, okay, and see all these many stars, all right, you want to know where they all come from, and what does it mean that there's so many? How did they form like this? Why did this cluster form like this? Why is this star brighter than that star? I mean, all these things you want to know. And then it hit home because we're around just one of those stars that are out there. Our planet circles one of those stars. Unbelievable, So, we have a lot of reason to wonder about our night and where we come from in our world. So that's why. Now, while we're here, I'm going to take us down to this little guy right here. It's a little tiny star cluster called NGC 6834. Let's zoom in a little bit. Okay, and I'm going to move just to the region. So we're going to go right now, and here we go. Bam, stars zipping by. Okay. Yeah, and there we go, and it'll be there, and I want to show you what happens. See, when stars form in these clusters, sometimes they can stay cohesive and stick with their cluster, and sometimes they migrate away. And let's go see what we got here. I'm checking out something in the D. Smith says, my daughter can't say dwarf. It comes out dwarf. Yeah, well, you can tell her our son is a yellow dwarf. I think that's hilarious. That's so cute. Wait a minute, she's 23? Okay, it just went from being cute to being a little bit weird. I'm sorry. Dwarf. I still think that's funny. Wow. That is funny. Okay, so we're here. Let me move up a little bit. All right, so we move the telescope up, and now what I'm going to do is do a 6-second at 8,000 again. Why not? And now we'll head back over to our view. Just a minute. And there we go. There's that little cluster right there. You say, well, how do you know? Well, experience. We've seen these clusters before. And you can see that this set of stars, they all form together. And how do we know they're all together? Well, because by analyzing each of these stars individually, we saw that they're all about the same spectral type. That is to say, the same color, the same relative chemical composition, and the same age, basically. And so by studying stars' atmospheres, you can get an idea of how old they are, where they are on their evolutionary scale, and it all comes from looking at the spectra. Astronomy is one of those sciences where you can't touch anything that you look at. You only can see the light coming from it. And that's what we do. We analyze the light coming from these things. And that's where we get all our information. Can you imagine if we were wrong? Yeah, I know. It's very possible. You know, it's possible that we don't know. Well, I know we don't know everything. But you know what? There's a difference between if you're in science and you say, we don't know what that is, to saying that it's impossible. For instance, UFOs. When you tell someone that you believe that UFOs are just a consequence of a race that's advanced, and they've managed to, apply the distance between the vast distance between these stars, including our own, well, then you have to say, okay, it's not ridiculous stuff to say that. It actually is logical. It makes perfect sense. But I think it's just science that we don't know yet. And because we don't know the science, we don't know just how much is out there for us to know further, So UFOs are a consequence of the advanced civilizations in this galaxy or universe being farther ahead than we are. And that's all there is to it. I believe that they exist. It's not like a religion. It's not because I have faith, praise the aliens and things like that. I'm not like that. It's just a scientific plausibility. That's all. A scientific plausibility. And for anyone in science to deny that is to illustrate that scientific ignorance, which is really something I rail against. I don't want to see ignorance. I want to see the open-mindedness. Because the open-mindedness brings the theories and the hypotheses about the many different possibilities out there for life. And that's it. That's it pretty much in a nutshell. So let's go take a look at some other things while we're here. Let's jump over to our wonderful planetarium here and go check something else out. Okay. Now let's see. We're looking there. And I know that some of you would like to see some of the things that we have already been looking at. And we're going to, for instance, the Dumbbell Nebula here. The Dumbbell is a famous planetary nebula, and we call them planetaries because of the fact that they appear to look like planets in a low-power telescope. And we just want to make sure that they're not, and so we classify them as what they are. And the Dumbbell Nebula is actually one such dying star that has a white dwarf at its center. The problem with the Dumbbell is very simple, and that is it's actually very sensitive to poor seeing. So when you have a night where the seeing isn't that good, all right, or the sky transparency, as we call it, is also not good, well, then we end up having some problems. And so what we're doing now is, we're going to take a couple of exposures here. We're going to go at 8,000 for 10 seconds. Okay. And we'll see if the Dumbbell shows up better than it did earlier when I looked at it. We have some very high clouds here, that's all. Ronald asked a question, as a MUFON guy, oh, there we go, look at that. Actually, it's not so bad. As a MUFON guy, do you think that these craft that we're talking about are going the distance or are using some kind of teleportation? It's only speculation, isn't it, Ronald? But the fact of the matter is, I think they're actually circumventing the speed of light, frankly. What do I mean by that? Well, let's suppose that the civilization originated at the star that was here. Okay, Dumbbell Nebula, just over 1,400 or so, 1,600 light years away, perhaps. It's actually difficult to get distances to these nebulae. And that star right there in the center that you see, that's the white dwarf that now comprises the powerhouse, which causes this gas to glow like you see. Well, we've talked about that whole ionization and recombination process that makes it glow, so I won't get into it, but I could come back to it. I'm not stifling that talk if you want to. But let's suppose that there was a group of civilizations out there, a civilization that actually needed to get away from their star because it was going to do just what this one did. And what would they do? Well, they would actually probably look for a planet like theirs. And if they could find a planet like theirs, little dynamic processing here for you. If they could find a planet like theirs, they would probably then try to move to it. They'd probably try to transfer all their people, ships, and move to the planet and live there. Well, lo and behold, they get here and they find out we're here. Well, in order for them to get here, I suspect that they're just circumventing the speed of light. Now, the way they're doing that is akin to warping space and bending space, kind of like what black holes do. And this is kind of neat stuff. And if you look this up online, I'll give you the spelling too. It's called the Alcubierre drive. Okay, that's ALCUBIERRE. Alcubierre. And Miguel Alcubierre in 1994 suspected that maybe with the right amount of energy we could build what's called a warp bubble around our ship, which would warp the space around us, but not just around us, but around us and any destination target we're trying to get to. So we would actually compress the distance from us to our destination and lengthen the distance between us and our origin, where we started from. Thus, we would actually travel essentially by folding up the corners of a piece of paper so the points almost touched, and jumping across the 2 points so we don't have to traverse all the distance along the paper in between. So it's sort of a interesting way to travel, because it would actually give us the ability to travel apparently way faster than light speed, but with no consequences, because we as beings, solid beings, cannot go light speed. If we do, we are converted to energy. And what's that energy? It's massive. Okay, you take your mass and you multiply it times the speed of light squared. Okay? Now the speed of light squared is 3 times 10 to the 10 centimeters per second, or 3 times 10 to the 8th meters per second. And you multiply that times your mass, you can see that's a big number. It's 186,282 miles per second. And if you wanted it in feet per second, you can see that's a much bigger number. You have to multiply that by 5,280 feet in a mile. So clearly that's huge. Then when you look at that, if you look at that situation, okay, you'll see that we have an amazing. Hang on a second. I'm just getting sidetracked by something. I apologize. Gosh, that was amazing. I actually read a comment in the chat, and it made me want to jump into something else, and I completely got derailed on what I was talking about. I'm so sorry. If someone puts in the chat what I was talking about, I'm sure I'll jump right back in and finish the thought. But weird guy, he was saying the universe was 14 billion years old, and is 92 billion light years wide. Actually, that is true, but actually kind of maybe not be true. It might be the universe is about 1 billion years younger than we thought. It actually might be just over 12 billion years old, between 12 and 13. Little errors that added up to large mistakes. And that 92 billion light years wide, people say, well, how can that possibly be? If it's only, say, let's use the classical number, 13.8 billion years old. How could it be 92 billion light years in size? Because 92 billion years basically is is a distance. In light terms, right? 92 billion light years is a huge distance. That's how much light travels in a year, 6 trillion miles. Okay, that's a light year. And like the distance to the nearest star is 25 plus trillion miles. So when we talk about oh, thank you, Albireo. Yeah, when we talk about looking at a 13.8 billion year old universe, you have to remember that the universe has been expanding ever since that light was making its way to us. So the point at which that light was emanated, the cosmic background radiation, which is what we see out to, the point at which that light was radiated to us is no longer yet that point. The universe continued to expand beyond that. Okay, and it was expanding, and now it's expanding faster and accelerating because of the dark energy component as well. So when you add it all together, and you add all the distances together and all the size, it comes out to be about 92 billion light years in diameter. Fascinating. Hello, Laura Newbert. It's so nice to see you here. I haven't talked to Laura in a long time. She's wonderful. So it's so nice to see all of you guys here. And I'll go back to my point on the Albireo drive. Let's suppose that the beings in this, at the Dumbbell Nebula here, had to escape their star. They could fold space and make their way to us. And you might think, well, how could they do that? If it's 1,600 light years away, how could they? Would it take them 1,600 years to get here? Well, only if they could move at the speed of light, but they can't. That is the speed limit in the universe. Okay, is the speed of light. But in our physical universe, the X, Y, and Z all moving through time, our 4 dimensions, it has a speed limit. All right, cannot be violated. However, if we jump outside that boundary, if we actually use the Albireo tensor system to actually generate a warp bubble, we could fold up the corners of our universe and jump tip to tip in the corners and not have to traverse the in-between. That's kind of how I look at this, how I look at Albireo. And believe it or not, I've made this statement before. We're only 5,000 years into what we as human beings have done for written history. From around Sumeria on forward, that's when we started actually documenting our history. In Sumeria, it was pegged into tablets, okay, as opposed to being written on cave walls and things like that, and pegged into rock like the petroglyphs. It was a more established language, and it's only 5,500 years or so in the past for us. But in that time frame, we already know how to go interstellar. We just can't do it yet. So you see, within a cosmic blink, this race of beings on this planet called Homo Sapiens has figured out how to go and circumvent light speed and be able to get to much further distances in the universe very, very quickly. Just a simple blink of the cosmic eye. See? So I have no doubt that since we came along about 9 billion, just over 9 billion years after the universe formed, I have no doubt that an advanced species could have come into existence before the Earth was even formed. and then found their way, up their technology chain and made their way here. That's very possible. And if they did that, well, then we could have been visited for hundreds of millions of years, if not billions even, at various times throughout our history. We don't know. And that's another reason why I had to get into astronomy. There was this 9-year-old kid in me that was always looking up at the sky, wondering everything I just talked to you about, other than Alcubierre, because I couldn't even say Alcubierre back then. And I didn't even know about Miguel Alcubierre back then. In fact, Miguel Alcubierre hadn't even come up with his postulate about the warp bubble and this, when I was wondering about the weird things that we could do in the universe. And as a kid, you're not limited. You're not limited by the facts, so you tend to have this innocent wonder. Could we go faster than light? Could we do that? Could Star Trek be real? And as it turns out, all science fiction so far that we've come up with, almost all of it, has become science fact. If Captain Kirk had the iPhone in his hand at the time that Star Trek was out, okay, I'm sure he would have said, "Scotty, we've got an advanced race here. They have communication devices that we have never seen." I said, "I think we do. Shall we reverse engineer them, sir?" You must do that, Scotty. We have to do that. I mean, I can see that happening, right? So we would actually have a leg up on Captain Kirk in this particular instance. And I think that's really funny when you think about it. We love our science fiction, but I don't think that we can actually think of anything that's patently impossible. I think because of the structure of our brain and the way we're made, I don't think we can actually think of things that are truly impossible. I just don't. I think that's just the way it is. I mean, could I be wrong? Sure I could. But what I don't think is that we would have a Captain Kirk coming here to saying, "Scotty, beam me up. There is no intelligent life here." I think there is intelligent life here. And I think any alien beings that are here know it. And they know that we, like the Zephram Cochrane of sci-fi, are eventually going to blaze our trail out into the universe and leave a large signature that they're going to be able to see for a long, long way away. But I don't know if it'll be Vulcans that are going to find us first, as in the Star Trek universe. But I think it's a pretty cool a notion to think about. So while we're here, I figure I'm going to take us to our planetarium, and I want to run over to another very beautiful planetary nebula that we've seen before, okay, called the Ring Nebula. All right, and we'll check it out right now. Let us to go see. And you can see the stars whipping by as we get there. That was Chiliac, one of the stars in Lyra that just zipped by. It's right near where the Ring Nebula is. Let's make sure the telescope is stopped. And it just stopped as I did that. Okay. All right. You can see in the telescope cams here, we have plenty of clean aperture looking out of the dome. And let's do 10 seconds at 8,000. Actually, I'm going to drop that down, because the Ring Nebula is pretty bright. So let's go 4,000 for, let's do 8 seconds. Why? I don't know. I'm going to live a little. We're going to live a little and see what happens. All right, Marianne, you have a good evening. I will see you on Monday at Sky Harbor Airport, because I will be there in Arizona, making my way to Arizona another time. I'll be there in September again as well. I'll be speaking at the International UFO Congress. This time I'm going out there to speak in Sedona and in Show Low, Arizona. They're about 100 miles apart. But guess what, guys? The skies out there in Sedona's got some light pollution, so I'm not 100% fond of it. But Xolo is completely free of that. And let me tell you, it's stunning. And I can't wait to see it. I really can't. I want to say hi to the folks that are here. I already said hi to Laura again. And DPFX is here. Nice to see you. And Genghis is here. Good to see you too. Let's see now. I'm going to also make sure I catch your questions. Oh, and this is the Ring Nebula, by the way. Right there. That ring is just a beautiful, beautiful. I'm doing it. It's a beautiful planetary. I'm doing it like this to show you. You can see it looks a little fuzzy. That's because we're actually looking at it through some little bit of high clouds. But you'll notice that the telescope doesn't seem to care. It's still actually able to show us some really nice views regardless. You know, and that's something that's really important. So let's do this. Let's kind of make it look as best we can. All right. Genghis, what's so strange about strange matter in neutron stars? Well, first of all, the words neutron and star go together only courtesy of our exploits in science that determine that there's a certain point at which neutrons start pushing back when they're trying to be compressed on the surface of a star. And that pressure that they push back with is due to their degenerate state. It's called neutron degeneracy pressure. And it's the next stage of degeneracy pressure over the electron degeneracy pressure that happens on the surface of white dwarfs, which are not as massive and not as small and as neutron stars. And in the white dwarf, electron degeneracy pressure keeps the star, cohesive at that point. If it gains a little more mass, it could collapse further, but usually what it does is it explodes and forms a type 1a supernova. These are supernovae that occur because the star is not supposed to be heavier, more massive, I should say, than 1.4 or so masses of our sun. That's the magic number. And that's called the Chandrasekhar limit. And in a neutron star, well, a neutron star has a very narrow range that it can exist in as well. And it can also do the same type of thing. When a neutron star goes or acquires more mass, it could either collapse further into a black hole or it could be disrupted as well. The surface of a neutron star is as hard as a billiard ball. I mean, it's really this degenerate material that's really super compressed. And neutron stars are tiny. I mean, you think of stars, you think of them like the sun is 865 million miles across, or 865,000 miles across. I'm sorry, and it has millions of times the intensity of a red dwarf star sometimes. Okay, but a neutron star is tiny. A white dwarf might be about the size of the Earth. A neutron star can be the size of Manhattan Island. All right, and both the white dwarf and the neutron star are very, very hot. Most of their energy could be emitted in the ultraviolet. And that's why, like we see here in this image, this is the Ring Nebula. That's why in this image, for instance, this Ring Nebula has this little dot in the center. And that's the white dwarf in the middle of the Ring Nebula. And its ultraviolet energy is causing the gas that was expelled. This used to be the envelope of the star. Right here, this stuff right here used to be in the envelope of the star, and what it has become is this rarefied material that is glowing because the ultraviolet energy from this white dwarf in the center is driving the electrons off of oxygen, hydrogen, and other atoms of gas that were in the surface of the star. And the electrons recombine and they drop to certain points in the atoms when they come back down. And those certain points they drop to correspond to a certain color, a certain wavelength, as we say. And so we're seeing here oxygen in the blue, a little bit of hydrogen in the red, and there's some neon and other materials too, but you can't really see them in this image. Kind of, sort of. But then in the dumbbell, you have the same kind of thing. You'll notice that all planetaries have this rich assortment of materials in their envelopes that they've sloughed off over the time of their death of the star. And that material is really interesting to watch. And when you watch this, when you see this happen in the models, you notice that the shape the nebula takes on is never actually the same in every case. Okay, the ring nebula looks like a ring. Now, for the longest time, I thought this was sort of like a sphere. And at the edges, from our vantage point, I figured it looked like a ring from everywhere you looked at it. Because I figured that maybe you're seeing through more material along the edges, okay, than on face on and in the front and back. But there's been some research to suggest that maybe we're actually coincidentally looking down a long tunnel. And this nebula is actually possibly a bipolar type nebula, where it has lobes coming out of one section or another, and they form little lobes like you see in the Dumbbell Nebula in our previous view here. Okay, the Dumbbell Nebula, and here's its white dwarf in the center. Okay, it has this distinctive hourglass shape, right? And we just took this a few minutes ago, and you see the orange and reddish view of the hydrogen here with the neon, and you also see the oxygen, doubly ionized oxygen, which is the O3. It's called O Roman numeral 3. I remind you that O Roman numeral 1, O1, is the base state of oxygen, where it's a normal atom with all its electrons. You ionize one electron off, that's what ionization is, where an electron gets pushed off the atom. And now that it's actually, that's singly ionized oxygen, okay, and so that becomes O Roman numeral 2. Single with a Roman numeral 2 is very confusing, I get it, but you have to remember it's like counting from 0, 1, 2, 3 versus 1, 2, 3. Okay, so we don't say O0, we say O1, O Roman numeral 1. Okay, so anyway, so we see here with the Dumbbell Nebula, we have this shape to it, and there's been some recent work that suggests maybe we're seeing coincidentally down the throat of a similar type of bipolarity. Personally, I think we're looking at a sphere. How about that? I kind of defy that research a little bit, because I think that in their haste, I think that they're misinterpreting some of the results. That's just my feeling. I read the papers. I don't know if I believe that. Dee Dee, welcome. Hey, you know what? I gotta say, I want everybody to know, Dee Dee was in the hospital, and she was public about it, and now she's out. And Dee Dee, I just want to say from the bottom of my heart, I am very happy you're okay. All right, and I'm very glad you're with us. And trust me, as someone who has had a few medical issues, I kind of know that it's nice to be thought of once in a while. So I've been thinking of you often here. Not to belabor that, I know that that's her thing to go through. It's her private thing, but I just wanted you to know that we're thinking of you, Dee Dee. So yes, this is the Ring Nebula, and it's kind of funny. Astro Live, you said you never saw the white dwarf in the middle. It's okay, it's sort of faint, frankly. It's I think it's just over or 14th magnitude or fainter, 14 and a half maybe. So in a regular telescope, you might not see it, but you might see it, else at other times. And you also see it in the dumbbell here. Okay, there's the white dwarf in the dumbbell. Okay, and we took that one a little earlier. So again, the odd thing is, when people look at these planetaries, one of the things that's kind of interesting is that you can determine how extensive they are. If you look at their composition, typically the nature of the white dwarfs is pretty much the same across the board. So you can kind of predict how far out the gas from the star will go before it's no longer being ionized and made to glow. And that value is something around a light year or so. So whenever you look at a planetary nebula, you're not going to see gas illuminated out further than about a light year. It's pretty interesting that we know that. It's because white dwarfs are pretty much textbook. They're kind of all the same, and like black holes don't really vary from each other than in their mass. Okay, white dwarfs have a very limited range of mass they can have before they're either a neutron star or a black hole or a supernova. So the white dwarf stage is fairly understood, as is the neutron star stage now. Black holes, of course, are understood to the point that they're understood. And if anyone wants to hear about how that picture of the black hole that's made the rounds is so famous, if anyone needs to understand a little more about that, let me know and I'll be happy to tell you if you have any questions about that. So going back here, okay, we were just right here in our constellation of Lyra, the harp, or the lyre, okay, as in the lyre, see, the lyre. And we're kind of playing around up in the Cygnus and in this region here. But let's check out a few other things. Like right down below it, there's this little guy. Okay, this is M56. Let's check it out. Let's go south a little bit and check out M56. M56 is a globular cluster. And we don't see it right now, okay? But that's because it's faint. And if we wanted to see it, we can actually go into like 4K mode here. That's 4K, and then I can increase the exposure a little bit. And then we should be able to see it. And we just do right there. Do you see it? Dead center. Yeah, the telescope's doing very well these days. I've got it really aligned well. Okay, so we're going to shut this off. We know it's dead center right there. And what I'm going to do is I'm going to drop my ISO, the sensitivity of the camera, down to, go down to 10,000, and we're going to go up to, say, 10 seconds. So 10 and 10. 10,000 for 10. All right. First of all, let me just make sure that, yeah, we're all set. Everything is cool. And off we go. We're going to take a 10-second photo here and see what we get. Hey, I hope you guys like going for this little ride here with me on tonight. Wasn't sure I was going to be streaming, but I decided I was going to do it. That's why, Daryl, you didn't hear from me, and I just wasn't sure I was going to, and I wasn't planning on it, and then all of a sudden I was. It's like, wow. Sometimes we do that. So here's this little guy, this globular cluster. Now let's take a look at the globular cluster and get a better idea of what we're talking about. M56 is a beautiful globular cluster, and if you look at its distance, okay, it's literally, it's 3,900. Well, it says it's 3,900 or 3,200 light years away, which is actually pretty close. That's actually 32,946 light years, according to it right here. See the data. Okay. So it's actually not that close, of course, but it's actually closer than some. And you can see it now. Of course, M13, Measure 13, is huge in the sky compared to this, and the biggest one ever that we've seen is Omega Centauri. It's actually one of Daryl Mason's favorites is Omega Centauri. And if Daryl's still with us, he can attest to that one. I can tell you that. And tonight, unfortunately, because we have a little bit of light cloud cover, clusters are better to see than nebulae, unfortunately, for tonight. But that's okay. Okay, so that's where that is. That's M56. All right, and there it is. And I have to just going to add a little processing into that, just a little bit more. Let's do that, shall we? We'll do that. Okay, so you watch your screen, you'll watch this processing now. You'll see a little bit of change going on here. Right, there we go. Okay, a little more. All right, here we are. See, less is more. Less is more. Yep. Okay. So that's a beautiful little globular that hides in the middle of this region. All right, and I have to see. Yeah, see, I have to make sure it's in Lyra, okay? Because if you notice these boundaries, these are the constellation boundaries, and this is Lyra the Harp, right there, and you can see that M56 is in that boundary. All right. Now, let's go check out, okay, let's see, NGC 6791. This is a very interesting cluster as well. And let's go over to that, and then we'll keep on going. I got something else in mind to show you here shortly. All right, so we're moving in. The telescope is lining up, waiting for it to come to rest. If you're out there, when it stopped moving, you right there where it stopped moving, you hear it go beep. Lets us know. Oh yeah, Astro Live. We did some beautiful shots of the Crescent Nebula and the Veil, and there was some nights last year that were so astonishing that they took my breath away. So I say that patience is a virtue with this stuff, and you know better than most actually that it's a real good idea to just take lots and lots of photos. I don't know if you stack your photos. We stack and then share on the SkyTour LiveStream Facebook site so people can see them. I haven't been doing any of that lately because I have a new camera rig actually, which is just for the camera, and I'm taking it with me to Arizona, and it's a little tiny motor that drives the camera at the same rate as the Earth, so I can just point the camera at the sky and let it go for minutes on end and get a beautiful photograph of the Milky Way and wide expanse of sky that you just can't do without one of these drives. And the unit was about $300 for the unit, but you spend some time. There's an app on the phone to get to help you line it up with the North Star, like you have to line it up. It's really cool. Okay, we're gonna take this picture now of this cluster. And again, what cluster is that? Well, it's this cluster here. It's NGC 6791 right there. Okay. This square box delineates the shape of the telescope field, and that angle shows us that it's actually looking sort of down. See, it's looking more toward the northeast. And as you watch, when we go toward the south, okay, look what happens to that red box. See what it's doing? When it's perfectly horizontal, right there, that's directly south. See? And that is actually where we are looking right now. You see, now we're looking over there to the northeast again. I just hit a different star, so I'm not at 6791 anymore, but I'll get us back there in a sec. Okay, and here it is. Yep, right there. Okay, so let's go over here, and now we're here at 6791. We just took that picture. Let's go check it out. Now here's what I like about this. Okay. Remember I told you about those M stars? Look at this right here. we got this beautiful star right here. All right, and we looked at this the other night, and Daryl looked at this and said, wow, is that star real? He said, because it stands out, doesn't it? Well, this is a carbon star. It's most likely a carbon star. It's a star that has a lot of carbon in its atmosphere, and it's a giant star. Now, it means that it's an advanced stage of evolution, and it's probably gonna end up being a star which is going to just become a planetary nebula of some kind later. Not necessarily a supernova, but look at that. It's sort of like an unnatural shade, isn't it? And that's what we see with carbon stars. They form this unnatural shade. Beautiful. Here's the cluster that we're looking at, by the way. You can see it there. It's very faint in here. And then you got that one star out there. Boy, that's something. And I can tell you right now, we know for a fact that this star does not belong with this cluster. Why is that? Because all the stars in the cluster are about the same age and spectral type. There's really not much difference. Now in Puppis, during the winter, there's one cluster that seems to have a planetary nebula in it. And it's not. Yeah, Daryl's right. This was the most interesting thing, and we're looking at it again, Daryl. And I did it because of you. Because you liked it. It's almost like we missed this cluster because we were looking at this star. But look at that color. It's just fascinating. And what I'm going to do, actually, is just before we move on to the next thing, I'm just going to actually go ahead and do one thing here. I'm going to actually set this up to go 12,800, and we're going to go 15 seconds. Not 20, 15. And I want to see the saturation of the color from that carbon star. I'm pretty sure that's a carbon star. So let's go over to our view here. There's the star, and if I zoom in, it'll come in. We should see it. Okay, it comes in again. The cluster is pretty clear. Look at that. Isn't that amazing? That is really so beautiful. So beautiful. So let's go over now, and let me see if I can just modify this a little bit. Wow, look at that. Isn't that pretty? That's really pretty. I want to play with that again. See, it's like my mother would always say, stop playing with your stars. Oh, Ma, I want to play with my stars. So then I'm going to go like this and drop it down just to show you the color. I mean, look at the color. That is just amazing. Let me just do this here first. All right, and then here. Yeah, I can't do that. Okay, hold on. All right, I want to go here. All right, and then here. All right, and now we're going to, I'm going to play with this here and get this to work. Wow. That's a beautiful star. That is one beautiful star. Can you imagine being on a planet going around the star like this? I mean, it'd be very far from the star because this is a giant star. But boy, oh boy, that would be so cool. Everything would be orange. You wouldn't know the color blue. Actually, blue would look black under this star. It would look kind of like dark, muddy. You wouldn't be able to tell what color it really was. There's probably no such thing as blue on a planet like that. Amazing stuff. All right, so let's go back over to our planetarium show here. And let's grab us one more thing. Let's take... Well, I don't mean one more thing. Literally, I'm just saying another thing. Let's go to the Foxhead cluster, shall we? And this is interesting. It's good to go on these wonderful cluster tours, because we find all these amazing things lying in wait for us in a constellation. We never ever see them. We never know. You know, we never see them before. We haven't seen them before. You know. So let's see now. Okay. Yeah. All right. So I think we are set here. We are. Let's take an exposure. We'll do 15 seconds at 12,800 again. Dee Dee. If a snowflake makes an appearance again, you're going to have PTSD. That's funny. Yeah. And this is, look at that. Look how rich these clusters are. Isn't that crazy? This is up in Cygnus. Look at this. This, you know, you say you don't see these clusters with your eye. You just don't. But look at all the stars here. Look at all those stars. If you think about it, it's like, wow, every one of these stars is powered by hydrogen. So there had to be a lot of hydrogen made, especially considering the mass of some of these stars. Hydrogen is the most plentiful element in the entire universe. So clearly, there was a lot to make a lot of these stars. Look at everywhere you look, stars. Everywhere. And they're all at different distances. So, very, very cool. Now let's talk about that cluster for a little bit. It has more than 100 stars, by the way, in it right here. There's more than 100 that are part of this cluster. And then if we come back, again, you get all this information. It's called NGC 6819. It's also called the Octopus Cluster. And why? I don't know. Does this look like there's any semblance of an octopus? Maybe, with little things sticking off. It seems like there's little bands of stars. So maybe it could be kind of an octopi. I don't know. I can't tell you. But it is interesting, nonetheless. It's too bad that we don't have a good, clear sky tonight. And so what I'm going to do is take us over now to this guy right here. This one's one I've been working towards for the evening so far. Okay, it's called the Blinking Planetary. You'll see the telescope is moving its way. Yeah, we're getting there. We're fine. And the Blinking Planetary you've always recognized because this double star is right there next to it. I'm glad it looks like an octopus to you, D. Yes, Ronald, there is gold up there, especially if you have emerging neutron stars. It seems that those precious elements were made, a lot of them were made with merging neutron stars. Okay, we're going to go 10 seconds for, I don't need to go as high here, so I'm going to go 8,000 for 10 seconds. Here, we're going to look at this guy right here. All right, let me make sure we stopped. We are. So here we go. Must be approaching 12:30 because I noticed the color of my lights in here has changed. My programmable lights are changing here, so I can go to this, which is fine. Okay, and now let's go 8,000 for 10 seconds here. And when we come back, what are we going to see? There we go. Check it out. And you see this beautiful double star, which, by the way, looks a little reminiscent of another double star that we actually saw earlier, doesn't it? See this? kind of looks like Albireo, doesn't it? Albireo was a B star with a K star next to it. The blue star looks like it's about similar, but this star seems to be a little hotter, meaning it's not quite as orange. And I'll see if we can find out what that is, what type of star that is in our planetarium. Here is our little planetary. Now this guy is called the blinking planetary for a reason. You'll notice that we've had a little star walk there. You see that little dashes? So we're going to get rid of that. Let's go back. Just do a quick 10 seconds at 8,000 again, and it will overlay this image right here, and we should see the good image come back right around now. And oops, there we go. That's better. No, is it? It's not quite as good still. Okay, I'm going to do one more. Why? Because I'm a glutton for punishment. That's why. Never ask a glutton. Okay, so let's get out of here and let's go over to here. And we should see it momentarily. Here it is. Okay, well, that's about what it's going to be. So apparently that was just a double star there. So yes, this is the blinking planetary. It's called that because when you look at it through an eyepiece, it can sometimes appear to disappear and reappear. It's a really small, compact object. You know? And Ronald, I don't know if you were here earlier, but I mentioned it's that blue because this is what we call the forbidden transition of oxygen. It's O3, which is doubly ionized oxygen. And when the oxygen is ionized, it means the electrons are jumping off the atom because they're being hit with energy, and that energy comes from the white dwarf in the center, which you can see there in the middle, the white. Okay, and this white dwarf ends up hitting these gas, these elements and these atoms here in this gas, which is the former envelope of the star. And so it ionizes them. And sometimes one electron jumps off, sometimes two. And when they recombine with the atom, where they go, when they go back into the atom, the energy level they drop to in the atom when they go, forms a characteristic light, or gives a characteristic light off. It's this wavelength. Now, the atom's electrons go to many places in the atom. And when they recombine, they go to many places. It turns out that the predominant one, though, is this oxygen 3 location, oxygen Roman numeral 3 transition. That's the O3, or doubly ionized oxygen. And that is the one that causes this blue color that you see here. It's just a wonderful, it's just a beautiful view. And, you know, you've heard Amanda say she loves the Cat's Eye Nebula. Well, it's a planetary nebula. It has this function, this thing going on in it the same way. It's very, very cool. If anybody wants images of these, I'll be happy to give them to you after I do a little processing. So that's the blinking planetary. And now let's see if I can get us up to something else. I know I can. I'm just trying to move it now. Let's go see if let me go see if the dumbbell is in. Yeah, the dumbbell's in a better position now, so let's go see. Sorry, I'm losing my voice. Let's go check out the dumbbell again. We saw it earlier. It looked like it was a little bit ragged. Let's see if it's gotten any better tonight. Of course, I probably sound ragged. All right, here we go. Oh, I recognize that star field, so the dumbbell's going to be nearby. That's one thing, you recognize star fields too. Okay, well, let's see. When the telescope stops moving, we'll get our north, south, east, and west lights back. That's the feedback loop from the observatory telling me that it's finished. But if it doesn't finish, then I can just hit this button, and it'll force it to finish. So now it's forced finished. Let's do 10 seconds at 8,000. Oh, D asks the question, with all the stuff we do, is it possible that we might come across something that has never been seen? Yeah, it's possible. It's definitely possible. I'll tell you why, because the universe is a dynamic place. For instance, during the lunar eclipse, the last lunar eclipse, what did we see, D? That only 5 other groups saw in the whole world. We're one of the 5. And who knows in chat what that was that we saw? Hey, Tim F., good to see you. And I'll answer your question in a moment, Tim. Okay, so who remembers what we saw during the lunar eclipse that was actually, yes, that's right, a lunar impact, D. D. Smith got it. Yeah, we saw a meteor strike the moon during the lunar eclipse. Wasn't that cool, guys? I mean, we actually saw a meteor hit the moon. So in other words, we don't have to many times, yeah, that's right, Laura. We don't have to many times look for new things. Sometimes they just happen, and we'll witness them if we're looking enough. I'll give you another example. I was looking at Jupiter one night when I lived in the old house, and I just had my telescope outside, and I was looking up at Jupiter. And I noticed these I noticed these dark spots appearing on Jupiter, and I thought it was my eyes. And I realized later when I started looking it up and everything that was actually Comet Shoemaker-Levy hitting Jupiter. And it was leaving these black scars on the upper cloud decks of Jupiter. Really incredible. So if you want to see something that hasn't been seen before, you basically keep looking in the sky, and sooner or later you will. Okay, another thing you can see, we image galaxies a lot, as you guys know. And when we image galaxies, one of the things that we do is we check against existing images of galaxies. I never do this with you guys on the air, when we're here. I do it later because I want to make sure that what we're looking at isn't something that hasn't been seen before. So, for instance, when you look at a galaxy that's out there in the sky, and you see a dot in it, a star that is in the middle of it, sometimes that's a field star, one that's in our galaxy, and we're looking past it to the galaxy, millions of light years past it. But sometimes it's actually a supernova in that galaxy, which will mimic and look like a star in our own galaxy. So we have to go by the other existing imagery of the galaxy. I've never found a supernova yet. Boy, I really love to. That'd be fun. I gotta do this one again. I apologize. I didn't realize that it had walked. Oh, Tim, you're welcome. And Tim's right. If you don't look, you won't see it. It's like the lotto. If you don't win, you're not gonna play. You don't play, you're not gonna win. You can't win if you don't play, basically. This is a much better shot. You can actually see that white dwarf in the center of the Dumbbell Nebula, quite pronounced there. It's beautiful. Now you see, if I take 10 of these and stack them, or 15 of these and stack them, I could eliminate all this noise. I've got an algorithm now that allows me to remove all the noise. What's the noise? Well, the noise is this stuff. All this modeling you see. I can get rid of all that and even it out and make it, a much better photograph. But Tim, I got to answer your question, or mention this to you. When you folks are with me here on this stream, that's what it's all about. You know how it is. Sometimes we see satellites, and you know this. We've gone hunting for satellites. We know where there's geostationary birds, and when we look in the sky for them, we can sometimes see 2, 3, or even 4 satellites at once because we know they're there. Now they're the geostationary satellites are moving along at the same speed that the Earth is rotating, but the stars don't move that speed. we're rotating out from under the stars. So if we're tracking the stars with our telescope, then it means that the telescope is very slowly moving, basically across the Earth. It's panning a little bit in the sky. As the stars rotate, so too does the telescope. But the geostationary birds are sitting over the same spot on the Earth. So if we're tracking the stars, the geostationary satellites leave a little trail. If we weren't tracking the stars and just sitting on the face of the Earth and looking up, then the stars would be streaked and the geostationary satellites would show up as black, as just little dots, because they're over the same spot. So it's the opposite thing. So anyway, that's the truth of that. And this actually came out really nice. I'm just gonna try another one just to see what we get here. So 10 seconds at 8,000 seems to do the trick. I really liked how that looked. So I'm gonna go back to that here. Let's go here. Let's see. There's another one. Did it come in just as good? Yep, it did too. All right. Well, you know what? I'm gonna push my luck. I'm gonna keep going here and see what I can get. And this is what you see with your eye. Okay. Through the telescope, you might see a little faint smudge in here. A small telescope. On a larger telescope, you'll actually see a lot more. All right. And here's another one. Okay. That's a little walky on that one. Okay, and we're gonna keep going just a little bit more. I just want to have something to stack for you so I can show you. And this is the Dumbbell Nebula through poor seeing and poor transparency. That is to say, the two parameters that we astronomers love to just talk about. Yep, there's a good one. So let's go back to this. Yeah, see, that's good. Okay, now we'll go back to here. And take a picture. And the more pictures we take, who knows? Maybe we'll get a satellite going through the field. You know, with all the Starlink satellites that Elon Musk put up, we should be able to see something cranking through our field at some point or another. Unfortunately, that's going to be the case, you know. Sooner or later, every photo is going to have a satellite in it. And I'm not looking forward to that, actually. Not at all. Okay. Okay, another one. Very good. This is nice. So we're getting some really nice shots of the Dumbbell Nebula at 8,000 ISO. We could probably shoot at 4,000 ISO for 15 seconds, but I'm just trying this. I was actually gonna not stream tonight and go up to Colbert, Connecticut, which is a much more darker sky site, and take my the tracker I bought for the camera is called Sky Tracker Pro. Look it up. Sky Tracker Pro by Ioptron. And Ioptron makes these tools. You have Sky Guider Pro and Sky Tracker Pro. Ioptron makes these so you can actually put a camera on a tripod with this thing underneath it, and it will track the stars just like your telescope does. And so whatever lenses you put on the camera, you can actually get a really cool view. And we can stream that too, by the way. We can stream the Ioptron view as well. I don't have it set up for that now. This is looking beautiful, isn't it? But I can see some artifacts of the light clouds. You can too. They have some fringing going on, and what's called the color noise is pretty high, which I'll point out to you in a moment. Okay, the color noise you see in the red here, that's color noise. Generally, that color noise is caused by the clouds. Okay, another shot here. Okay, hold on here. Well, that's a particularly nice one. That's a very nice one. I'm pleased. That's a good one. Actually, Tim, that's a good question. He asked, with all the space junk out there, I mean, how in the world, do they do this without hitting each other or getting hit by something? Well, honestly, it's very rare. Why? Because space is big, and as much junk as we have up there, we don't have so much that it actually is causing a major issue. At least not yet. We do have to calculate. We do have to calculate the placement of every bit of debris. They track, items as small as bolts that got away from astronauts on the shuttles while they're installing something. These bolts or tools or a tool bag, just a cloth bag, can rip through a spacecraft and destroy it entirely and utterly. Especially at the speeds that the spacecraft will be going. A spacecraft will be going 17,500 miles per hour. That's pretty quick. And if you hit a 2-pound cloth bag at that speed, wow. Now, it's also moving at some speed. And, of course, satellites, they all move in the direction that the Earth's rotating generally because it's easier to launch in the direction the Earth's already rotating. Okay? And, which way is that? Which way is our Earth rotating? It's rotating toward the east. All right? That's the way things set in the west. Okay? The stars are rolling out from under us, or we're rolling out from under the stars from east to west. So we're rotating toward the east so that those stars will move to the other side and head toward the west. So we generally will launch satellites toward the east so that they actually have the benefit of already moving 1,000 miles an hour when they leave the Earth. Just over 1,000 miles an hour. One more here, and then I'll move on. I just think the dumbbell's looking pretty, and it's a sort of a pre-summer preview. You can see all the color pattern and modeling in here. We're not going to get one as good as the that other one I shot without the clouds in the sky, but this is looking pretty. Really is looking pretty. The telescope is behaving very well. Okay, let's go over to our planetarium. Righteous is here. Righteous Toad is in the house. Welcome. Welcome to SkyTour LiveStream, Righteous. Alright, well, there's a NGC 6886. There's a little planetary there. Let's go check that out. Okay, we're heading there now. Actually, I'm not quite heading to the right one. I'm heading to this star. I don't want to head to that star. I want to head to this. So I'll head over there. Actually, I should be able to head there. Okay, so let's go back to our view here. And we're still fine looking out these camera views. You can see where the telescope's pointing. 10 seconds at 8,000. Let's see if we can see this little planetary. 6886 is small, but we should be able to see it. You'll look for the distinctive bluish green color. Okay, do you see it? I can see it. I don't know if you can. Let me actually give you a view that will actually help you see it. I don't know if you can see it. It's right there. See it? There it is. Let's go down there and grab it. Where'd it go? My mind just went blank. It's right there. All right. So there's that little tiny one right there. Remember what I said? There's a certain distance beyond which the white dwarf in the center of these cannot ionize the atoms anymore of oxygen, right? Because the ultraviolet energy, the energy falls off or diminishes with the square of the distance away from the star. And there's a certain distance where you can calculate that the ionization energy isn't high enough. And that puts the star, or puts the size of the nebula with a definitive outer limit. So obviously this nebula is, well, I'll put it to you. Is this nebula closer or farther away, say, than the Ring Nebula or the Dumbbell Nebula? Knowing what I just told you, you should be able to figure that out. You would know that this nebula right here, if it was the size of the Ring Nebula, it would be about the distance of the Ring Nebula. If it was the size of the Dumbbell Nebula, which is about this big on the screen, okay, that it would be actually, it would also be the distance, say, of the dumbbell. But because it's so small, we figure that it's probably a lot farther away. Okay, so kind of cool. Yeah, I know. I look for all these little things that you just don't expect to see, you know. But that's what I do. This is the coolest stuff. You know, and this is what we do when we don't have the best sky to look at. But we do have a really nice sky here where we are. We see a lot of stars. Okay, so I'm going to find... okay, yeah, we haven't looked at this guy yet. We did look at M56. But we could look at the angelfish. So let's go to the angelfish right now anyway, just to check it out. Okay, and we're pulling in. You can see the stars moving in there. I have to tell you guys, it's really the coolest thing in the world when you can sit in here and operate the telescope in beautiful warmth when it's frigid cold outside. And it's really addictive. If it's clear, you got to do it. It's like, I got to look at stuff. I got to look at stuff. I got to look at stuff. I'm spying on the sky. That's a little creepy sounding, so don't remember I said that. All right. 8,000 for 10 seconds. We're going to be looking at the angelfish cluster, which should be a little globular cluster in the view. There it is, dead center, right where it belongs. Okay, let's check. Let me just get there again. Here we are. Oh yeah. Little instant processing. It's actually taking a little of the brightness away. It's brighter than that. Very cool. Okay. Yes, sirree. Nice. Very nice. Interesting about these clusters. These globular cluster stars are stars that are very low in what we call metals, which are anything other than hydrogen and helium. Anything other than hydrogen and helium are labeled metals, even though they're certainly not metals. Okay, you know, carbon is not a metal. Okay, but obviously we deem it as a metal because it's the nature of how we talk about the chemistry of the stars. It's more of a traditional hangover from the past rather than actual reality. But these stars are metal poor. So it means that if they're metal poor, it means that they have mostly hydrogen with helium in their cores. They don't have magnesium and calcium in their atmospheres. They don't have carbon, oxygen, and nitrogen. They have just primarily hydrogen and helium, with a few other variations. So the chemistry of globular cluster stars is something that has been studied for a long, long time. Because they're population 2, meaning they came first. Older stars, some of the stars are as old as the universe itself sometimes. So they live and last a long time. So very telling objects. They give us a lot of information. Now, let me see if we've got anything else to view here. Yeah, there's plenty to see. I just don't want to waste it on a bad night. I would love to actually show you a really, really good night. We imaged this actually one night. This Gamma Cygni Nebula. We imaged that. Here is another cluster. It's called the Little Sisters. Let's go there and check it out. It's also called the Cooling Tower. I've never seen a cooling tower cluster. Believe it or not, this will be the first time. Okay. As you can see, no, actually, I've got to. There it is. As you can see, I have to just kick back on this camera here. Sometimes they go offline, and I just don't know why. It wasn't offline. It was just actually. It was just. It just shuts itself down. Okay. So this is the cluster. Let's actually do 10 seconds, but not at 8,000. Let's actually go down to 3,200 for this one. Not 2,500, 3,200. There you go. Okay, ready? Let's go. 10 seconds at 3,200 on the Little Sisters. Okay, we're going to see it pop in now. And there it is. What a beautiful little cluster. Look at that. Isn't that pretty? I just think that's really pretty. That's just beautiful. Sorry, I was reading chat here. Yeah, Laura, there's some interesting research going on with the habitability quotient. It's not becoming incredibly pessimistic though for life, so don't worry. In fact, it's probably points to even more possibilities for life. And the reason is manifold, but not the least of which is that we know that M stars have the most planets in our galaxy, and there are more M stars than any other type. They outnumber the other stars many to one. So it's probably the same in other galaxies, and it's probably also true that these other galaxies will have planets in the same type of quantity. So that's like saying it's reduced the number of habitable planets from 40 billion in our galaxy to 31.6 billion or something like that. So in other words, not a real practical reduction. But that's something interesting, It's all interesting. Look at this little glittering jewel box. Isn't this beautiful? This is the sisters cluster. There it is. I want to do this one for a little longer. So let's go over and Let's do this for 20 seconds. Yes, 20 seconds. So it'll be 20 seconds now. Genghis, I would love to see the Magellanic Clouds. I've never seen them in my life. They're a southern object, unfortunately. Boy, oh boy. Dee Dee, thank you for dropping by. I'm humbled that you came to see us. And we'll talk to you again soon. There we are. It walked a little. We're going to do better. Boom. And now we're moving. So let's go back to our view here and grab that particular view. And let's see what we get now. This should be better now when we come in. So this will overlay as it comes in. Let's see what we got. And what do we got? There we go. Much better view. See? Isn't that pretty? It's amazing how this little jewel box, from out here, it's like, oh, look at all these stars, look at all these stars. Then we gotta zoom in. Here's a little jewel box we're looking at. Pretty cool. Actually, I think that's pretty interesting to think about. We look at the Pleiades here, and it's very bright in our winter sky. It has this beautiful nebulous cloud that it's passing through, which is why it's there at all. And then we have this set of stars here. And what if these stars are some other planet's Pleiades? See what I mean? And they don't have to have one, but I'm just saying it's really an interesting way to think about it. Wow. Well, Daryl, it might be warm in Australia, but depends who you are. Because maybe if they're up in Darwin, it'll be warmer than if you're in Sydney. But I don't know. They're in winter right now. And Daryl's correct. If you see the ESO Very Large Telescope time-lapse photo, look that up. ESO VLT time-lapse. And you'll see those Magellanic Clouds going through. What are they? They're these two dwarf galaxies next to our own. There's the Large Magellanic Cloud and the Small Magellanic Cloud. Very cool and very exciting to see. I can't wait to see it in real life. Just cannot wait. Australia's on the bucket list. Yep. Gonna go to Australia. Yeah, so the cooling towers, also known as the Sisters. Okay, and now this is called the P Cygni cluster. And let's go see it. Zooming away here. Wow, look at that little guy right there. This is going to be really interesting. I just saw something up here go through. Did you guys see something whipping through there? Right up top here. Let me know. Okay, let's do a shorter one. Let's do 10 seconds at 4,000. That's right, it's winter down there, Daryl. Wow, look at this. Now this is a really special little cluster. Check this out. Look at that. That little complex cluster. Isn't that beautiful? That is so pretty. I wasn't, my cursor, my cursor wasn't moving at the time, I don't believe. So, you might want to go back and look. Whatever the time was, it's 0:56:32 now. It had to be 2 minutes ago and forward. I'm wondering if a satellite had whipped through the view, because that was a live view we were looking at. Look at this. This is really pretty. This is really astonishing. I've never seen this cluster before, guys, so I just think it's kind of interesting to see it now. Look at that. What a beauty. And it's actually time to do that a little different now. Let's do 15 seconds. Let's be crazy. Let's just jump up to 12,800 for 15 seconds. Oh, I'm mad, I tell you, mad. My stream health looks good, by the way, so I don't think you should be lagging. Wow. Yeah, look at that. And now you actually see more life in this cluster almost. I don't mean life particularly, like life, but I mean just it's just beautiful. How about now? We'll do some instant processing here. Look at all those stars. Look at all those. Wow, that is so pretty. Really pretty. That's the P Cygni cluster. Let's just remember this, because we'll be coming back to this one for sure. I really like how when you have these really bright stars in here. Yes, I remember Land of the Lost and the Slee Stack. Yeah. Do you remember the song was really kind of interesting. It was Marshall, Will, and Holly on a routine expedition. Had the worst earthquake ever known. Remember that? What happened? And they said, plunge your tiny raft 1,000 feet below to the land of the lost. And they had these really bad actors in masks that were like the Slee Stack. It's like all they did was this hiss. It's like, oh man. And remember Chaka? A member of the Pakuni tribe. Oh yeah. Ota, that was water. Yeah, I remember really strange things. Oh yeah. Yeah, I'm kind of a idiot savant when it comes to themes. Don't ask me to do HR Puffin stuff. I can do that one too. And Mr. Red and everybody else. Oh yeah. Yeah. What else are you gonna do in an observatory at night? I mean, the acoustics in there are just phenomenal. I had a huge dome, man. The dome was like 40 feet across. That's like it was wonderful. I could sing to myself and the sound would come back and it would sound like I was harmonizing with like 4 other people. And what, did I ever record it? No. No, not at all. Why would I record it? I always had it at my disposal. Anyway, it's a beautiful, beautiful little cluster, I gotta say. All right, let's go and we won't say goodbye to that cluster, but we will say adios, amigo, until next time. Let's run into our planetarium program and check it out. Okay, remember, folks, the P Cygni cluster. We're gonna check that out again. Yeah, it's just beautiful. Wow. Okay, what's this? Interesting. I have never seen this. Revenant of the Swan. Permanent supernova? Or permanent nova. Interesting. We're going to look at that. I want to see a permanent nova. Don't be fooled. It's going to be just a normal looking. Looks like it'll look like a normal star at first, but not to worry. Okay. Well, there it is. I will be doing some research on this one, folks. I want to check it out. Let's just do a dynamic zoom on this right here. Let's see if we can check it out. Oh, I don't see anything spectacular about it yet. Okay, not yet anyway. But let's do 15 seconds at 12,800 to see if there's even a hint of some type of nebulous detail, which I don't know about. Keep looking. This looks like a regular star to me, doesn't it? Yeah, it sure does. Huh. Well, let's see here. A little bit of walking at high detail there. I'll find out some more about that next stream and figure out what that was. Revenant of the Swan. Daryl, if you're still there, check it out, will you? Go look that up and see what you think you can find, because I'm just poking around here. Okay, this is a cluster associated with some nebulosity. Typically, oh, I just realized we got a satellite in that Revenant one. You didn't see it. I'll have to show you. Yeah, it's down below here. Let me see if I can just show you that satellite really quick here. And we're gonna go into the Stellarium view, the viewer, and let's grab. Let's see if I can grab this. Where am I looking? Oh, not that. Wrong one. Okay. Oh. No, it's not going to let me. Oh, poo. I was hoping to show you there's a little satellite that was going through the field, but you've seen them. We've seen satellites, I know. All right. So where are we now? I went to this little guy right here. And let's just see if we can view that. I don't know if we can, but we'll try. All right, let's bring up our view here. Okay. All right, and we stop the telescope because it won't stop by itself right now for some reason. And now let's do, I will do 15 seconds because it's supposed to be nebulosity. Okay, 15 seconds at 12,800, and supposedly there is some nebulous detail associated with that star. Let us to go see. I don't know if there is. We will see. I don't know if it was that. Or that might be that. It might be. It's a little off center. Oh. Okay, let's go see where this is supposed to be, huh? All right. Okay. All right, so it's supposedly centered on that guy right there. So that means it's right in the middle of the view. Yeah, that's what I thought, those little stars. Well, let's go see. One more time. There they are, right there. Okay, yeah, look. See that? So technically, there might be some nebulous view there. Technically, there might be a little nebular view. Nice. Little nebula that I could see. I could see that a little bit there. Let's see if we can do a little processing on that. Okay, that's a little bit. Shows it a little better. Interesting. All the stars have a reddish hue here, you see? That's really cool. I'm finding this stuff fascinating. You see what happens when you go through just the clusters? They're often overlooked, but look at the gems we found. You know, the P Cygni cluster, this little cluster. Gorgeous. Really, really pretty. Okay, now I'm gonna try and just, because it's a little higher in the sky, I'm gonna look at the Crescent Nebula, which I know at least one of you is interested in out there, because we're talking about it. But tonight is not the night to try and find it, because it's actually going to be rather subdued behind a little bit of the high altitude clouds. But you know what? We're going to look anyway. You'll see a remnant of it. Something of it will show up. And we're going to do 16,000 for 15 seconds. Ready? I'm not. Here we go. Let's try it. Sorry for the crunchies. That's the pop filter on the microphone. Here we go. Alright, so we should be popping in just a second here to see the crescent. Oh, it is there. You see it? There it is. See it? Right there, you see it? And it comes down here like this. You can see an edge of it there. Well, that's cool. It actually shows up right there. See it? Right down. There's a brighter area of it. Curves down. Comes down around. Yeah, it shows up. That's pretty cool. Let's try another shot of it. Let's do 20,000 for 20 seconds and see what we get. Here we go. I'm daring to do 20,000 for 20 seconds. 20,000 for 20 seconds. Scotty he's mad. I said he's mad. Mad as a hatter. Yes, it's true. I'm mad as a hatter. And why are hatters mad? That's what I always wondered. Okay, well, this is interesting. Okay, you can see 20 seconds, 20,000. You can actually see it a little better here. Let's try and do a little processing. Oh, that came out a little better, doesn't it? Oh, yeah, that's pretty nice. So let's go in and play with that. We must be able to play with this a little more. Oh, so you can see part of the Crescent Nebula right here very clearly. See that? Nice, nice, nice. Daryl, you were away? What? That's okay. That's okay. Fantasy, thank you for coming by the way. I don't think I greeted you and said hello yet, but thank you so much for coming along for the ride and hanging out with us. Always good to see you. Yeah, that's pretty good for the Crescent Nebula. Not bad. You can see a little bit of it here. Alright, as the weather gets better and as the skies improve, as the season progresses, it'll all be much nicer. So we're gonna check it out let's go back and check out something else. Let's see if I can. I'm doing all this without even moving the dome because we're looking out at the one spot where it's just beautiful. As I say that, I'm thinking about moving. You know, see, Cygnus is really kind of on the edge here, and I know I won't really see much. Okay, if we go down here to the veil, but I'm gonna try it anyway, just to kind of give me an idea what the night's like. I know that the night won't be, typically isn't that good if we got these high clouds like this. It's exactly the wrong night to look for things like I'm about to try and look for. But we'll do it. We'll do 20 seconds at 25,600. And it looks like we're still good in the telescope view down here. And what do we got here? The telescope is still moving, but we know it's where it has to be, so I can stop it, force it to stop. And now we'll do 20 seconds at 20,000. 20,000. Yeah, there are astrolive. There are many nebulae in Cygnus. Okay. Will we see the veil eastern remnant? Yes, we will. There it is, folks. Right there. Look at that. Right there. It looks beautiful. And let's process a little. Look at that. We have the full filamentary structure, even though it's a very poor night. Check it out. You can see it's really, really beautiful filamentary structure here. You're looking at the remnant of the most cataclysmic explosion that a star could undergo. And it was a supernova. Probably because there's a lot of iron, isotope 56 of iron, in fact, in the core of the star. And when it finally went off, all of that was released into the interstellar medium, as well as everything in the envelope of the star, which of course is oxygen 3. We can see here a little bit of hydrogen and neon and other elements that have color signatures similar to what we see here. Pretty cool. This is really pretty. It came out nice. I'm actually going to play with this just a little bit more, guys. I'm just going to go in and do what I call tweaking. They're going to tweak. And not in the same way as people that do tweaking. Alright, what do we got here? A little better. A little better. How about if I do one more thing here? Let's turn on... Yeah, a little bit of sharpening is almost overkill here. Let me make sure it's off, on, off. Okay, yeah, we're going to leave it off. That's beautiful, huh? Look at that. Nice, nice, nice. Really happy with that. And if we're doing this side of the veil, we should probably try and do the other side of the veil as a comparison, don't you think? Yeah, me too. So let's go over to our planetarium program, and we're going to go over to 52 Cygni over here, and we're going to look at this part of the nebula. Okay, so here we go. Okay, that's 52 Cygni right there, and this nebula goes up and down right here. We should see that pretty clearly once the telescope stabilizes. Oh, and it has already. That's good. So let's do 20 seconds at 25,600. That's cool, Tim. He's playing medieval fantasy music in the background. I don't know how that fits with my music, but okay. Yeah, okay, here's 52 Cygni. You can see the vertical spire right here. It's a little bright, but let me just see if we can process that away. Alright, now we process that quickly. Oh yeah, look, you see it coming right down here. Wow. Oh yeah, I'm telling you, this is why astronomy is so much fun, my friends. This is why it's so much fun. You just can't get enough of this once you start it. Didn't I say I was only going to go about an hour? And I think I broke that rule again. I'm at 2 hours, 16 minutes, 17 seconds. Oh, man. I'll tell you what, though. I do have to get up early tomorrow, so I do want to let you know that I thank you very much for coming tonight. I am going to call it. I still have to go out and close down everything out there manually still. I don't have automated systems yet to close the observatory, which I will have for Arizona, of course. So I will talk to you guys the very next time we do this. This was, I call it an accidental stream. I actually wasn't intending to stream tonight, but I saw this guy and said, you know what? I'm going to stream anyway. You guys have been waiting, and it with the light cloud cover, it was the equivalent of light chop that you see in an airplane. You know, the light chop, it makes the ride a little less comfortable, but you still get to take a nice ride, and it's not that bad. And that was like the cloud cover tonight. Not that bad. Very, very high, thin, translucent stuff. You know. Hey, Astro Live, I'm glad you did, because it's a lot of fun. If you have any questions offline, you can certainly ask me. You can reach me at SkyTour Radio at kgraradio.com. That is our email. If you have any questions, guys, actually, if you want to ask me a question, send me a message on Facebook. You can find me on Facebook, of course, at SkyTour LiveStream. You can also find me as Mark D'Antonio in Facebook. So feel free to come along and send me questions there if you have any, or if you have ideas for targets or so forth. Do so. And like I said, I'll be there with Amanda on Sunday nights. We're going to be doing the SkyTour Radio. Our show on Sunday nights, I'm really humbled to say, it's really gone like gangbusters, and this weekend's actually going to be fun. We're going to talk about volcanic upheaval on the early Earth and how that relates to life on other planets around the universe. It actually, by looking at what happened here, we're learning great lessons for what could have happened there. And as I was saying, our shows are really good. They're getting a lot of attention. SkyTour Radio on KGRA is actually typically, for its time slots, number 4 or number 3 or 4 across the iHeartRadios and TalkStream Live. So the rankings and ratings are good. We're reaching 3 million people per month now, and that number is actually climbing. So we're really excited about that. And there's cool opportunities that come out of this too, and if any of you want to be guests on the radio show, send me a note. And if you've got something cool to say, then I'll bring you on. Daryl Mason's with us a lot, actually. He's becoming a fixture there. And of course, Amanda Curran is the co-host with me. But let me know what you want to do. I think it would be kind of cool. I don't have a problem with it. I share the spotlight always. I don't feel like I have to hog it. You guys, have made SkyTour LiveStream something I didn't. I just had the equipment and put it all together a little bit, I guess, and I put together the showmanship side for you. Because look, come on, pretty pictures, man. It's a beautiful scene. You want to see stuff. I like to explain what's going on and everything on the screen and let you know. But, you guys are really the ones that made SkyTour LiveStream what it is. I wouldn't be broadcasting to nobody. I'm very happy that you guys want to come along, and I'm very humbled that you do. So I want to thank you for that, too. Thanks, Justin. That's very kind. And I've heard many very kind things from a lot of you guys, too. So I just love what I do. I really do. I'm aching to get this telescope under a dark sky. Oh, man. Really am. So, that said, the only thing I'm aching for now is some sleep. Today, let's see, I had to fix the rider mower. The gas tank split, and I had to repair it. It's a polycarbonate tank plastic. And I can tell you how I repaired the polycarbonate tank if you ever have a problem with a tank like that splits. I'll tell you how to fix it for good. And then let's see, I ran and got some more clothes for the Arizona trip because I have a habit of wearing out pants for some reason. So I had to get a few more, and then I got myself a nice shirt for my talk because I always like to dress the part. I don't show up in a t-shirt and jeans to do a talk. I think that's disrespectful to the audience. They're there to see you. You stand out. You should look different. You should look like you are in a position of standing out, worthy of the words you speak. So it's kind of cool. Anyway, I will let you guys sit back and listen to the music for a little bit, and I'm going to go shut down the observatory and take care of all those things that I've been talking about. I hope you guys have a good evening, and I shall come back the very next clear night. Alrighty. So, that said, I will talk to you later.